All right, graphing simple rational functions. This is problem 3 in the homework. So first thing I'm going to do is it has an A, B, C, and a D part, and we're going to basically name transformations, graph the function, state the domain, and state the range for every part. So the first thing we're going to do is name the transformation. So the negative on the top in the numerator, that's going to reflect across the x-axis. Okay. The 4 is bigger than 1, so that's a vertical stretch with a factor of 4. Okay, the x minus 3 here, where h is actually a positive 3, that's going to move the graph to the right 3 units. Okay, and then plus 1 is our k value, which moves it up 1. All right, so next thing we got to do is graph these things. And what we want to graph first are the vertical and the horizontal asymptotes. So the vertical asymptotes is always in the denominator. And for this one, our vertical asymptotes are VA, or VA. That's going to be where x is equal to h. And since I'll put an equals there, we can just make that a colon. That's where x is going to equal h, and h equals 3, so x equals 3. Okay, here in our k value, k here equaling to 1, that's going to be our horizontal asymptote, our ha, and that means that y is going to equal k, which in this case is just 1 also. So we have asymptotes, horizontal asymptotes at 1, and a vertical asymptote at 3. Again, vertical asymptotes, if you can't remember which one goes with h or k, vertical asymptotes only happen in the denominator, and that'll be for both forms. All right, so got a horizontal asymptote here at 1, and another one here at 3, vertical one at 3. Okay. So when I'm doing this in my brain, I've got this function in my head, and that's my parent function of rational. So that's where my curves are in respect to where the asymptotes are. So because this one has a reflection, the curve in the top right is going to reflect across the x-axis and become on the bottom right. So I'm going to have a curve approach each asymptote like so. Okay. Then the one that's in the bottom left is going to flip across the x-axis, and then it'll be here in the top left, approaching those asymptotes. Okay, and that's all you got to do to graph those very quickly. Then we use these asymptotes to help us figure out the domain and the range. So for the domain here, basically the only thing that intersects my x-axis is the vertical asymptote. So the vertical asymptote, your VA, is what affects your domain. So basically, here in highlighter, if I go across my x-axis, I can do all the values up to that asymptote. And right here at that asymptote, there's an opening because there's an asymptote through it. You cannot let that be a value, and that value is a 3. Okay? Then we can continue after that and get the rest of the x numbers. So basically from negative infinity to positive infinity. So basically we got negative infinity all the way to 3, union the other side of 3 all the way to infinity. Okay. Another way you can write this, x such that x cannot be wherever the asymptotes go through. So this vertical asymptote goes through the x-axis at 3. So x cannot be the 3 there. For the range, it works very similar, except you're going from bottom to top. Okay. This one's affected by the horizontal asymptote. Okay, and we kind of have the same situation. So in yellow, I'm highlighted here. We keep going up all the way up until 1. So right there at 1, we have an asymptote going through there, so we cannot use that number. And then the rest of the y-axis up into infinity. So to infinity here, negative infinity down here. All right, so our range is from negative infinity to 1, union 1 to infinity. Okay, or the set of y such that y cannot equal 1.